Okay, students. So let us see the optical properties. Uh, so as we discussed previously, the crux of this part is as simple as this: that when uh, any material is in the bulk form, whatever the optical properties it exhibits, like color, for example, will be quite different if the same material now you break into the uh, nano size powder. So that is the main crux. Most importantly, you will have to you should be able to write this in the words. Also, there is a little bit scattering theory uh, about the intensity, which you may remember I had explained in the optics topic, that if there is some section which has, I'm sorry, my previous video stopped suddenly and I forgot my previous marker open, so that is dried up now. So this will be a little faint, but point is, if you have some gas or any kind of dispersion, and if there is a finite intensity, light intensity going on, so light intensity passing out, or rather if you look it from this side, for example, this is, suppose this is a glass, so whatever scattered light passing out of it will have some particular value. So you can observe this intensity at various places. For example, if you also observe at this place, this intensity will have multiple factors involved. One of the factor will be how much the absorption of this material is. Now if this dispersion, if it is in the form of nano size, how does it affect? How does it affect the transmitted and scattered light? That is the topic to be discussed. So you can directly start writing that, because it is not long topic and not much to talk about it. Just start writing. You should be able to write this, as I said in the exam. Start writing. Colored glasses are made by mixing small amount of metal particles like gold, cobalt, nickel, etc. Color appearing is due to nanoparticles of metals of different sizes. Important point here is that color of nanoparticles are different from color of the bulk material. हाच एक महत्त्वाचा मुद्दा आहे बेसिकली. फॉर एक्झाम्पल, नॅनोपार्टिकल्स ऑफ गोल्ड गिव ब्राईट रेड कलर इन्स्टेड ऑफ येलो. ओके, फाईन. इथपर्यंत तुम्ही एक 4-5 लाईनमध्ये जनरल तुम्ही डिस्क्रिप्शन सांगितलं. फेअर इनफ. You can just write this scattering theory in words. Write it down. According to electromagnetic theory, when beam of light of intensity I0, when beam of light of intensity I0 or IO म्हणा त्याला, original beam of light intensity IO and wavelength lambda passes through a medium, the transmitted intensity is given by I equal to I0. I hope this is visible. This pen is not bold. Okay, I0 or IO into e raised to minus mu, where mu is extinction coefficient. You can just write it, I am dictating, where mu is extinction coefficient as n by mu equal to n by v into c ext, x for extinction. Okay, so where this is volume, v is volume, and n is number of particles, So moreover, this is enough to be able to write in the exam. So that is what it covers. Moreover, what is the scattering. Okay, and one more thing, this C-ext, this is extinction cross section of particles, extinction cross section of particles. So just put it in the words. So this is what you are expected to write in the exam, but just to give you some more information, again you don't need to go so much into deep here for this topic, but the idea is as simple as this. If you have suspensions, like for example milk is a suspension particle which has a nano size fat particles suspended. Okay, so whatever, if you have some unit amount of intensity falling on the volume of nano suspensions, how much you will get intensity transmitted will be that explained is by this theory, where this is, as I said, so this is the intensity you get at the right hand side, and that will be of course dependent on original intensity, what you actually put it at the first place, but also on the extinction coefficient. So this is good enough. So one more topic I would like to just quickly cover. So these are the main various properties you will be asked in the exam, which are magnetic property, electrical property and optical property. But just there are also some tiny description of some of the other properties, as we already discussed the structural properties in the last video, which was actually cut suddenly because my phone's memory got hoovered. Okay, so the next important point is the mechanical properties. And for this case the again crux is very simple. If you have any particular material, whatever its mechanical properties, like for example toughness or hardness, ductility and so on, these all properties, if I make these in finer form powder, in terms of nano scale powder, that will have much different properties than what it has right now. That is the main crux. You can directly write these some of the sentences. Generally this may be asked for just 2 marks, so not too much is needed. All main 3 properties can be asked for 4 marks, what we had: electrical, magnetic and optical. So just write few lines. Mechanical properties, write it down. Mechanical properties like elasticity, hardness, ductility are a direct result of composition and bonds between the atoms. Full stop. In the bulk form, imperfections in crystalline forms change these properties. For a nanoscale materials, the materials tend to form a single crystal, and hence nanocrystal are highly pure and free of any imperfections. Experiments show that metallic nanocrystals Young's modulus reduces dramatically than bulk material. So Young's modulus of metallic nanocrystal is reduced than bulk material. That is the point. ठीक है. So basically काय होतं आहे, Young's modulus हा कमी होतो than when it was in the bulk for metal. Okay. Next line, material hardness increases linearly in the bulk form as size increases of a grain of material. However, for nanoscale, grains of same material hardness decreases linearly as grain size is increased. So हे छोटे 2-4 पॉइंट्स होते फक्त. हे जे रिलेशन्स आहेत की ग्रेन साईज कमी कमी करत गेला तुम्ही, नॅनो साईज छोटी करत गेला, आता हार्डनेसवर काय होतं, डक्टिलिटीवरती काय होतं, यंग्स मॉड्युलसवरती काय होतं, एवढेच पॉईंट होते ते. सो दिस इज इनफ फॉर 2 marks क्वेश्चन. थँक्यू सो मच. सी यू टुमॉरो.